In this video, we will look at ionizing radiations, which is part of the GCSE science course, and it is also part of GCSE physics. This is topic 6 in EdXL, and I'm not sure in AQA what topic it is. There are 5 types of radiations that are emitted in a random process from a nuclei that is unstable, and you will learn about these 5 types of radiations. But more specifically, you will learn about 3 in more detail. Alpha, beta particles. You should be able to describe the nature of gamma radiation. Compare the penetrating abilities of alpha, beta, and gamma. And also compare the ionizing abilities of alpha, beta, and gamma. So the first thing to look at is, what do we mean by unstable nuclei or nucleus? So what I want to draw your attention to is the following, and I will highlight for you here the key thing. The nucleus of a radioactive substance, basically any atom that has too many neutrons in its nucleus is unstable. So any atom that has too many neutrons in its nucleus is unstable, and it will therefore, what we say, decay. So this is what I mean by it will decay therefore. Okay, decay means it will emit radiation. That's all we need to know at this stage. As it decays, it emits 3 main types of radiations: alpha, beta, both of alpha and beta particles, and gamma radiation. When this nuclear radiation interacts, or when alpha, beta, and gamma is emitted, this is the sign for gamma. When gamma is emitted, it interacts with atoms and causes them to become ions. And please remember from our understanding of chemistry that an ion simply is an atom or group of atoms that have either gained or lost electrons. So they can be positive or negative. In this diagram, you can see clearly that this is alpha. The red line, it does not go beyond paper, so alpha is absorbed by paper. Beta goes through the paper and it is absorbed by aluminium, meaning it does not penetrate aluminium. So alpha is less penetrating than beta. And finally, if we look at gamma, the green ray, it goes through paper, it goes through aluminium, and it hits lead, and it is absorbed by lead. So what we can confidently say is the following then. Alpha is the least penetrating, gamma is the most penetrating. So 3 important properties of alpha. It travels a few centimeters in air, it is most ionizing, and it is stopped by paper. Beta, it travels further than alpha, it travels a few meters in air, it is moderately ionizing, so it is less ionizing than alpha, and it is stopped by 3 millimeters thick aluminium. And lastly, gamma will travel a few kilometers in air, it is weakly ionizing, and it is stopped by thick lead or by slabs of concrete. So just to summarize for you then, and I will re-summarize this again, and I'll go one at a time. So in terms of ionizing ability, alpha is most ionizing, gamma is least. In terms of penetrating, alpha is least, gamma is most penetrating. In terms of range in air, alpha travels a few centimeters, beta a few meters, and gamma travels a few kilometers in air. That should say kilometers, sorry, my apologies. Many meters or a few kilometers, it makes sense. Description of each one then. Alpha is known as a helium nuclei, and I think the key thing, and I'll just change my pointer, the key thing to note here is helium has atomic mass of 4, atomic number of 2. Alpha, mass of 4, atomic number of 2. The only difference is helium is neutral, has no charge. Alpha has a charge of +2. So therefore, alpha has a charge of +2. has a relative mass of 4. We've already discussed its penetrating ability and its ionizing ability. In terms of beta, there are there's two types of beta radiation. That's what we call beta minus, which is the one we are discussing first. It has a charge of -1. Its property is its high energy, fast moving electron. Its mass is 1 over 1860 or 1 over 2000, and the other penetrating power we've looked at, it travels a few meters in air and it is stopped by aluminium. But we also have beta plus, like this, which we call a positron. The only difference between beta minus and beta plus, which is a positron, is the charge. Both have the same mass, both have the same penetrating and ionizing ability. Beta minus is -1, beta plus is +1. So the other types of radiation, beta plus, which I've already discussed with you now. The fourth type of radiation is neutron radiation. So neutron radiation is when radiation comes out of the nucleus, and neutrons have a mass of 1 and have a charge of 0, and this is covered in more detail when you study physics on its own. Lastly, gamma. Gamma is a wave. So please remember, gamma is a wave. Gamma has no charge, no mass. Beta we can write like this. B has 0 on top, -1. Alpha we can write like this, 4, 2. And beta plus, 0 and +1. And the neutron is 1, 0. So this is how we represent alpha, gamma, beta minus, beta plus, and neutron. So gamma has no mass, has no charge. It's the most penetrating, least ionizing. This is a really nice summary of what we've covered so far, and my advice would be to pause this video here and just take note of what's going on. In terms of speed, gamma travels the fastest and alpha travels the slowest. And a nice little matching activity which you can do in your own time, and few ionization questions which you can do in your own time. The key one I want to focus on is effects of ionization. They cause damage to good cells, so they kill good cells, and they cause cancer. Okay, this you can do in your own time, and then this is a nice little summary just to go over the summary for you. That's beta. Please note it's emitting an electron. This is gamma because it's emitting energy, and this is alpha because of 4, 2. And then what are the three types of radiation called, and what does ionizing radiation mean? We've already covered this. My advice would be is to pause and then look at the answers. I'll go through the slides and you can read this in your own time, and then please answer the questions. Again, alpha particles are large compared to the to the other types of radiation. Pause the question here and then answer. Same with the question on beta. Pause and then answer the question. Pause the slide here or pause the video at this point. Are beta particles more or less ionizing? And then answer the question, please. This is a good way to summarize for you. Gamma rays more or less ionizing than alpha and beta. Pause it here, answer the question. And that's the end of the video with the final summary. Alpha is most ionizing, least penetrating. Gamma is most penetrating, least ionizing. And the more penetrating a radiation is like gamma, the more thicker material you need, like lead or concrete, to stop gamma rays. Thank you for watching, and please like my video and subscribe.